All right, now I want to move back to a displacement time or position time graph, and I want to go through and do the whole question, showing all the steps just to make sure we're all good, and then I want to draw a connection or relationship going the other direction. So we got a couple things I want to do here. So y-axis is in meters, x-axis is in seconds because it's time. How do I go from dt to vt? Okay, and it is slope is the answer. Okay, so this is something that it's got to make it onto either a study sheet or it's something that's got to be memorized. So how many slopes do I have to calculate? Well, there's one line segment, two line segments, there's three line segments, which means I'll have to do three slope calculations. So slope 1, or angle V1, equals, I'm just going to go delta y over delta x, that's what you're comfortable with. So the change in y, so creating my right angle triangle, there would be a change in 4. And the time it took was also 4, and it was negative. So that means it was -1 meter per second, and I will put the forward again. All right. Next, in stage 2, I'll do it up here. So V2, delta y over delta x. So creating a new right angle triangle, we now have 2 to 5, so it would be 7, and the time frame I did that was 2, so that's 3.5 meters per second forward. And finally, stage 3, we're just finding the slope of each segment, breaking it into segments. Looks like the height is 5, it's negative, and the run 1, 2, 3, 4, so negative 1.25 meters per second forward. Okay. Going to a velocity time graph, then we end up with horizontal lines. So I'm actually going to use black lines will show up just nice. So the first one's -1 meter per second for the first 4 seconds. So that's what goes on here. So there is my velocity, my meters per second for the first 4 seconds. Next, positive 3.5. So I go up 3.5, and that was for 2 seconds. So 3.5, 2 seconds is up there. And finally, the last one's -1 1/4, and that finishes out the time frame. So there we go. We have created a velocity time graph. That's all there is to it. Now on the next slide, and I'll just repeat quickly, it'll be acceleration time graph. So with the acceleration time graph, you're finding the slope of VT. All right, so I'll go like this on my diagram. So we're going to find slope again, and have my red arrow coming in here, just so it looks cool. Now the nice thing again with today's lesson is that your VT graphs are going to look like this. They're going to be horizontal line segments. If you have horizontal line segments, that means that you can find the slope very, very quickly. So the slope at all points here, again, is 0. So throughout this entire trip, the acceleration will be a 0. Okay? And there we are. So, just as a recall, because I want to lead into something else here, if I'm going from position time to velocity time to acceleration time, again, you're just finding slope. All right? So going from one to the next, you're finding slope. Now let's talk about going the other direction for a second here. All right? Because that's what I want to do. I want to come back this way. How can we do that? Well, let's recall here for a second. All right. So if we look at how we came up with displacement, all right, so I'm looking at the slope equation, all right? So I'm going to grab one of these slope equations right here, and we're going to talk about it. That's what I'm referring to. So in order to find velocity, I took the slope of a position time graph. Okay, well, let's adjust that or make that formula a little bit more accurate. What does delta y represent? Delta y is your change in displacement over delta t. I want to find displacement now. So in order to do that, I need to isolate delta D, which means that I will need to multiply both sides by delta T. And if we multiply both sides by delta T, inverse operation, delta T's cancel. And we find that my displacement, delta D, is equal to velocity multiplied by time. All right, so in order to find displacement, I need to multiply velocity times time. So let's take a look at what that really means. If I look at this VT graph, you don't want to do this to yours, so I don't want you to mess up your note. But I'm going to take this segment right here. So this is where I'm focusing. If I take my velocity, which is this value here, 3.5, and I multiply it by time, time is here, which is 2 seconds, I would get 2 times 3.5 would equal 7. All right, now what are the units? What does the units tell us? Well, I'm going to redo that again. So 3.5 is my velocity. So 3.5 meters per second multiplied by 2 seconds. So the seconds would undo each other, cancel each other out. So I'm left with 7 meters. So when you calculate that, you are finding your displacement, because if you look back, the displacement was 7 meters. Taking that one step further, what are you calculating here? If you multiply 3.5 times 2, you are finding the area of this rectangle. So finishing that off, this right here is area under a VT graph. Which means that the answer up above here is we find area. So if you want to go backwards, if you want to go from an AT to a VT graph, you need to find area. Now, I'm not going to start with AT graphs today because area under that is 0. So it could be any graph. You draw any graph and it'd be correct. The example I have for us is that we are going to try going from a VT graph to a DT graph, and that is find area. All right, we'll talk about AT graphs a little bit in the next lesson, I guess. So, how do we find our DT graph? We need to find the area of every segment under the x-axis or under the graph. So that means I'd have to find the area here. So that's area 1. I would have to find this area, which is area 2, and this area, which is area 3. Okay? So area 1 equals all rectangles today. So hopefully that's not much of a stretch for us. 2 times 3, it's positive 6, and the result will always be meters. And I'm going to talk about that positive for a second. The reason it's positive is because both y-axis was positive and x-axis was positive. If we move to area 2, though, again, it's a rectangle. Length times width. So if you'd say this is the length, it goes for 3 seconds. Okay. The height of it, though, is -4. So it's equal to -12 meters. Finally, and we'll talk about what that will look like. Oh, actually, there's 4 areas. What was I doing here making 4 areas? Area 3, another rectangle, length times width. That's 1, 2, 3 times 1, which is 3 meters. And area 4, length times width, it's a rectangle, 1 times -2, which is -2 meters. So here we go. We're going to take each of those values, so I'll circle them. +6, -12, +3, -2. And we're going to have to cheat a little bit here. My graph only goes from 5 to -5, so bear with me. The first one, we're going to start at 0. A good place to start. And in the first 3 seconds, and I'm getting 3 seconds from here. This is the length of time for the first segment here. First 3 seconds, I have to move 6 meters forward. So my line is going to look like this. So yeah, it does go off the page a little bit. So we'll just add that on. 6. So there we go. There's our first displacement. All right. Now, in the second displacement, so I took care of that one, so I moved 6 meters forward in 3 seconds. In the next 3 seconds, I have to move back 12 meters. So that means that I'm going to go from positive 6 all the way down to negative 6 at 6 seconds. So somewhere down there. And again, negative 6. So that's how I moved in the second segment. So that's done. In the third segment, I moved ahead 3 meters. So the positive tells me to move forward. So I go from negative 6, and it lasted 3 seconds. So that's at 9. So I go up to negative 3. In the last segment, I have to move back 2 meters. And there we go. So we just created a DT graph from a given VT graph. So we just found area under the graph. Okay? The handout and the homework questions relate all to this. All right? So you just have to remember the most important thing. Slope moves you from DT to VT to AT. Area moves you from AT to VT to DT. Undoes it. Okay? This is that emphasis right here. All right? Can't stress that enough. Okay, so anyway, that was the homework. I'll leave you there. If you have any questions, please make sure you ask in class so we can get that clarified. Good luck.